Most things are designed by human beings. This toy, for example, this car, and this complex silicon chip. Design usually involves an exploratory activity in which parameters of the object are adjusted step by step. Parameters such as the thickness of this piece of wood, the slope of this windscreen, and the width of this piece of semiconductor on the chip. When the designer alters a parameter, a property of the object changes. The weight of the toy, the wind resistance of the car, and the power of the chip. With most objects that are designed, there are many parameters, each affecting many important properties. For example, the material of this toy affects its weight, its cost, its manufacturability, and its fire resistance. Now, the designer wants to create the best toy, the best car, and the best silicon chip. But because the quality of design is a function of all these properties, the design of the best or optimum object involves repeatedly altering the parameters until sufficient quality is achieved. For a human designer, this is a very difficult task, especially when conflicting properties are involved. It's not possible to have the best of all worlds, and the designer must find a compromise. This task isn't so difficult for a computer. The computer can automatically and rapidly adjust parameters until it senses that the design is optimum. But the computer has to be told by a human designer what is meant by quality, how to choose adjustable parameters, and what common sense limits apply to the design. So we bring the human and the computer together to exploit their different but complementary capabilities. The human first describes the object whose design has to be improved. Here, the designer of a hi-fi amplifier has sketched a design. But the predicted property is not quite satisfactory, so the designer defines the ideal performance. He can also draw upper and lower limits that should not be violated. By adjusting the height of these vertical bars, the designer can indicate the relative importance of different, perhaps conflicting design requirements. Then the designer is advised by a mathematical expert about optimization. The computer, with its optimization ability, now attacks a problem under the designer's surveillance. To help this process, we show the circuit problem symbolically, with the size of this circle representing the inadequacy of the design. The computer is attempting to reduce it step by step, often taking 20 or more steps to achieve a better design, represented by a smaller circle. But the quality of a design depends on many properties, each of which affects the performance. So we have a circle for each constituent property. For example, these lower circles show how hot the hi-fi gets, how poor the treble response is, and how much noise can be heard. Additional detail is always available. While watching how the quality of the product is being improved, the designer can also see how the parameters are being varied, because each parameter is represented by the height of a bar. And underneath each value bar is another bar indicating how sensitive the quality of the design is to that parameter. Of course, the designer would also welcome another friendly expert to warn him or her of any peculiarities and unexpected properties of a design, and generally to offer advice. This expert is, in fact, built into the system and attracts the designer's attention by activating one of these bulbs. When the designer responds, the advice is displayed. This display is called the cockpit. Like the combination of an aircraft pilot and an automatic pilot, our designer can observe the progress made by automatic design, but intervene when it's useful or necessary. The cockpit interface brings the benefits of optimization to designers in engineering who would otherwise not use it, thereby facilitating better and more reliable designs. The control and observation of circuit optimization, COCO for short, is based on the philosophy of blending together the different but complementary capabilities of the computer, the human designer, and knowledge elicited from experts.